All right, good morning, game makers. My plan today in this video is to finish up Catch the Clown. So in Piskel, program we've used in class to create some sprites, I just made a really quick strip of confetti. There's some red, white, and yellow that I plan to use. And we're going to create, for the first time, using a rigid body. So up here, I'm going to create a brand new scene. Now you'll notice that the scene doesn't even have a base node. What I'm going to do is say use other node, and what I'm looking for is the rigid body 2D. Now a rigid body is a perfect node or physics body to use when you don't need to have control over what happens to it. It's probably the most realistic in that it's affected by gravity, air resistance, and you can really configure it to behave as if it's interacting with the real world. And so we're going to go ahead and use the rigid body. I'm going to call it confetti. Just like any node, if we want the player to see it, we'll have to add a sprite. And the sprite's going to be a little bit different in that it's going to have three sub-images, what we call them in Game Maker. And so I have to go to animation here, and I have to say how many horizontal frames there are. And in this case, I made it so that there were three different possible choices. So frame is what we're going to pay attention to when we start to do the code, because we're going to have the confetti choose which frame it is that's going to be displayed on the screen. Rigid body also needs to have a collision shape, just like all physics bodies. So in this case, I would say that a rectangle makes perfect sense. And I'll have to zoom in, shrink that down, and enlarge this. And so the rigid body has a few different things in its inspector that you might not have seen in some of the other physics bodies. You can see that it has a physics material if we wanted this to be bouncy, or we wanted to affect kind of what it was made out of. We'd play with this. I am going to adjust the weight to something really small. And I'm also going to check adjust the gravity scale, because I'm thinking a piece of confetti will meet a lot of air resistance. And so it wouldn't fall like a lead weight. It would fall very, very slowly. So we're going to add a script to the confetti. And one of the things that we're going to need is, just like anything that's going to move, we have to declare a direction. And so I'm just going to make that an empty vector2 for now, and have the ready function determine which direction it's going to move in. It also is going to have a speed, and unlike Game Maker, you don't have to set a variable value here. You can do that later on when it's more appropriate. And I'm also going to let's see, what else do I need to set here? Probably nothing. So now in the ready function, that's where all of my action is going to take place. A rigid body, you shouldn't be trying to move it or applying move instruction every frame like we do with some of the other nodes that we've used. Generally speaking, with the rigid body, you only want to apply a force to it to cause it to move infrequently, or when it's absolutely necessary, so that then the physics can take over and for it to do its thing. So the first thing we're going to do is we're going to set the direction, and we're going to say that it's going to equal a vector2, and then we're going to use rand range -1, 1. So the x can be a float. Now a float is a decimal. So in Godot, the decimal, I think, goes into like the thousandths or millionths place. It could be a really small number, but left or right, and then up and down, we're going to do the same thing. And to make sure that it moves noticeably, we're going to normalize that so that the length of that direction is 1, no matter what these values are. Because again, they're not going to be normal numbers like we're used to. They're going to be like 0.5, 3, 7, 9, 8, or something like that. So we want to make sure that the length is still going to be 1. So normalized will do that. it'll change whatever that angle is and make it equal to 1 unit. And so then we're going to do a speed, and we're going to say the speed has a minimum of 100 plus, and then I'm going to use a random float. So this can be any number with decimals. It's not super important for us to have an integer here. We are going to do require an integer in a minute, but so we're going to say it can be anywhere from 0 to 150, and it really doesn't matter if it rolls a random number like 120.387894. We don't need a whole number there. Now, where we do need a whole number, though, is when we choose which subimage we're going to use. So the sprite, we're going to say, we're going to find the frame, and we do want the frame to be a whole number. So right now, if we go back to, let's see if I can do that without Zoom getting in the way. If we go back to looking at this, so our sprite, so we've got the node sprite, our frame, the red is frame 0, the yellow is frame 1, and the whatever color that is, white probably, the collision mask is, the collision shape is sort of blocking my view. So we can actually hide that if you ever need to. So we need an integer from 0 to 2. And so we're going to use yet another random function, and we're going to say rand I. So that's going to guarantee that we get an integer, a whole number. And there are 3 possible outcomes. Now, rand I on its own is going to start generating a random integer from 0. So there's 3 outcomes. We're either going to get a 0, 1, or 2 here. To make sure that our results are truly random, we can randomize. And it looks like that, Godot is telling me there's an error on line 11. So direction equals, oh, wait. Isn't, oh, this has to be outside. I'm sorry, outside of that bracket. And then rid of that, and I think that gets rid of it. So what it needed to do is it needed to first come up with this angle, and then we normalize it. I was trying to normalize the float of random range and the y, and well, obviously it's fixed now. So now we've got to cause this thing to move. And so a rigid body, one of the ways to get it to move is to apply an impulse or a force. And what we need to do is we need to define 2 things. An offset, if we wanted it to be as if the force moving our object came from the side or top or bottom, we are not going to do that. So we're going to say vector to 0. We do not want it to be offset or for that force to come from another direction. And now we've got to say which way we want it to go. And so we actually have that already. So we're going to I'm going to use a temporary variable here just to make this easier. So I'm going to say velocity equals direction times speed. Hopefully Mr. Shelton will appreciate the science that we're trying to implicate here. So vector 2, 0 means just go from its origin, and then we got to declare what direction we want it to go in. So we're going to say velocity. And so what should happen is we're going to randomize or shuffle the deck. We're going to establish a direction, normalize it so that that direction, whatever way it's heading, is going to be a length of 1. We're going to create a random speed, and then we're going to calculate velocity, choose a sprite from the available ones. So there's 3 possible ones. So we have a modulate 3 here, and then apply impulse is what's going to actually cause it to move. So if I've done this correct, if I can actually just run this scene with, but let me save it first. So save scene as confetti looks good. And then let me see if I can run the scene and we can see. So that time you can see it shows yellow. Let's see if we get a different color. No, that one's still yellow. And so, of course, I can go off in any direction. That was white. So getting it to head in the direction that's convenient for us. Oh, you can see it's red. So things are working. I don't feel like that I did the apply impulse correctly. There's something about that that I'm not feeling too good about. So let me see if I can quickly figure that out. So velocity is direction times speed. Um, well, maybe it will. So now, for the very first time, I'm going to show you how to take a scene and instance it into your game. So we're going to go into our clown, and we're going to create a new function, and that function is explode. So func explode. And so what we're going to do is when the clown is removed from the game, it's going to run this. We're going to make sure that it runs this command, but we have to prepare something first. And we're going to prepare the confetti to be introduced into the game. So I'm going to do something, and we haven't done this before, on ready. So that means when we are ready and the clown is in the game, we're going to set a variable confetti to be equal to, and we're going to preload a scene. So let me get out of this, and we're going to find our confetti scene. And so there it is. You can see it's got a little clacker. I don't know what those things are called. I'm going to right click it, copy path, and we're going to put that right in here. So when the clown is made, he is going to already, and it has to be a string. I don't know why it didn't for me. It is going to have in its mind prepared the fact that we're going to instance in some confetti. And so what that looks like is the first thing we need to do is say we're going to create a new confetti, and we're going to create more than one. So we're going to use a for loop. And the for loops that look different than they do in Game Maker. So we're going to say for I in range, and then inside of the parentheses, how many times you want to create confetti. I'm going to say 50. Then we're going to say new confetti equals a confetti instance. So anytime we reference new confetti, it is going to be a brand new instance of the confetti. So let me just make sure all that looks right. We have to give it a position. So new confetti position is going to equal the position of the clown. So it's going to appear where the clown is. And the last thing we need to do is put it in the scene tree. So I pointed, but we need the confetti to become a child of something. So we're going to make it the child of game. So we're going to get parent, add child, new confetti. And that's how you instance things in Godot. So, so here we go, 4i, all that looks pretty good. And now the last thing we need to do is a timer. So with game chosen as the active node, we're going to add a new node, and we're going to use a timer node. Unlike Game Maker, timers actually use regular human values. So wait time 1 is actually 1 second. There's some options here. One shot means that the timer will go off once. If this is not checked, the timer will go off once every second. In this case, that's what I want. If I want it to start in the beginning of the game, or whenever whatever the parent code is created, in this case, the game is going to start, obviously, then I'm going to go ahead and check that. So this timer is going to go off. The timer has a signal. And so the signal is timeout, and we need to connect that to our game. And in the game, you can see it now puts something here. So we're going to create a new variable in the game. So this you can see this is running in the game script. Time left, and I'm going to set that to 5 just for testing purposes. And every time the timer goes off, I'm going to take time left minus equals 1. So that's the same as saying set time left to -1 relative. And then we're going to have to check to see if time left is equal to 0. And if it is, what we're going to do is we're going to get node, clown, and we're going to run its function, which I already forgot what I called. Did I call it explode? Explode. I don't think so. Let's find out. So go to clown, function explode. So it looks like that is right. So function clown explode. Okay, and then I got to add to the clown that once it's done doing these things, then we're going to delete it. And to delete something in Godot, you say Q free, and Q free will remove that instance from the game. So almost ready to give this all a test and then hopefully not fail miserably, because doing this live is sometimes tough. I'm going to go to my label here. I'm going to rename this. No, I can't, because then it'll break something else. I'm going to copy. I'm going to Control D. And now I'm going to rename this timer. I'm going to drag this across. You can see that it still says score, so that's obviously not going to work. So we're going to say time left. Drag that into a better position. And because I copied and pasted it, it kept all of our font information. And so now all I have to do is when the timer goes off, we'll get node timer text. Oops, I got the wrong one. Timer text. I'm doing something wrong here. Oh, so I don't want the timer. I want the timer too, because that's what I see, because you can't have the same name in this tree. So timer text, that's probably a better name. So back to this, my script, timer text, text, now it's working, equals time left plus string time left. All right, I think I've remembered everything. I think in this case, I am going to run, I think I'm going to copy, Control C, Control V, and then that way, all right, well, let's find out what happens. So I'm going to run my game, and you can see time left is counting down. Let's see what happens when it reaches 0. And I did get confetti, holy moly. And you can see that that confetti is behaving and moving as if a real object in space. It's really a neat node. And I did forget to stop my clock, but that's an easy fix. But at least you were able to see that confetti effect. Now, you might be dissatisfied with the amount of explosion. And in that case, what I probably will need to do is make some adjustments in my confetti settings here. So I might go there and then say, well, I didn't like the damping. So here, applied forces. So right here, damping affects how quickly air friction stops it. So I could play around with that and say, well, let's see what happens when I do 0.5. Let me go back to my game though and stop my timer. So if time left is equal to 0, I'm also going to add get node timer stop. All right, so then obviously my game is over. So what I'm going to do is I'm going to go get node button show. Okay, but a button doesn't do anything yet, I don't think. So I'm going to go into my button. I'm going to go to the signals, so button, then over here, button, so pressed. So I want something to happen when it's pressed. Go to the game, connect the signal pressed to the game, and then when the button is pressed, then I'm going to say get tree reload current scene. And this is the same thing in Game Maker as restart game. So let's give it another try. Let's see what happens. So 3, 2, 1, boop, and my clown explodes. My replay button shows. This is what I was talking about earlier, where you can set it to have a different look when you're hovering over it or when you press it. And when I hit replay, it starts over. So that's it, guys. We have finished Catch the Clown, or at least the parts that I wanted to teach you about. And we've used a static body, we've used a kinematic body, and we've used a rigid body, all the different physics body types to create this game. We've added timers, we've instanced scenes, we've really explored a lot of what makes Godot great. So I'm going to end the video here, feeling pretty good that I didn't make any embarrassing mistakes, and I will see you all very soon.